Good day everyone, I am Geethanjali from the Department of Computer Science, IIT, University of Madras, here to present my paper on the identification and analysis of ransomware transactions in the Bitcoin network. The motivation for my research is can be attributed to blockchain as well as the ransomware attack. So, blockchain is the use of a public ledger to record all financial transactions, and Bitcoin is one example of a cryptocurrency that incorporates blockchain technology, and due to the security and anonymity provided by this technology, ransomware attackers are preferring to use blockchain to demand ransom payments from the victims, so that the payments are basically untraceable and the attacker remains safe. So this is the major challenge that security firms nowadays are facing with respect to ransomware attacks. The objective of my paper is to build a machine learning model which will be able to learn the pattern of ransomware transactions that have taken place in the Bitcoin network, and apply this knowledge to identify and classify future transactions as to whether they are involved in ransomware or not. So, coming to the literature review, I have taken 6 papers relating to ransomware as well as cryptocurrency, and most of these papers involved classification. The first paper, the authors decoded the proportion of cybercrime activities that take place in the Bitcoin ecosystem. They made use of multiple algorithms like support vector machine, logistic regression, random forest classifier, decision tree, etc., and among other models. And the highest model, the model with the best accuracy, was gradient boosting classifier, which achieved 80.76%. In the next paper, the authors tried to discover crypto ransomware attacks based on given data. They came up with their own technique of incremental bagging, which is used to select subsets of the data sets, and on these subsets they applied ESRS, or enhanced semi-random subspace selection, which is nothing but a type of feature selection, and they came up with ensemble classifiers which involved again multiple algorithms like the ones listed here, and their model was able to achieve an accuracy of 96.8%. In the next paper, the authors tried to detect ransomware payments in the cryptocurrency executing on Windows systems, and they made use of deep learning technique, and the algorithm is LSTM, or long short term memory, which is a type of recurrent neural network. The model achieved 98.25% accuracy. In the fourth paper by Dalal and team, the authors were able to identify miscreants involved in ransomware as well as gambling transactions in Bitcoin. So they came up with graph modeling, and on that they made use of ensemble classifiers and meta classifiers, and their models were able to achieve an accuracy between 96 and 99%. And in the fifth paper, the authors tried to identify, classify malicious accounts in a permissionless blockchain network such as Ethereum. They made use of time series analysis, principal component analysis, and cosine similarity. And they made use of extractive classifier for the classification task, which achieved 88.7% accuracy. And for clustering, again, they made use of multiple techniques, out of which DBScan stood out with 0.356 Celote score. And in the final paper, the authors try to identify and classify Bitcoin transactions as ransomware or not. They made use of SNN for binary classification, and SNN is shallow neural network, and ODT for multi-class classification. The SNN was able to achieve 99.9% accuracy in classifying the ransomware payments, and ODT, or optimized decision tree, achieved 99.4% in classifying multi-class problems. My research problem is to identify and classify transactions based on these selected features: length of transaction, count of started transactions associated with a particular address, and number of looping transactions that involve a same address, and number of neighboring nodes associated with a particular user's address, the weight of transaction, that is the fraction of payments being received by a particular user address, and the total income received by the address. So the methodology that was followed in my work involves collecting the data, analyzing it, and pre-processing the data, and finally data mining tasks is applied, where a machine learning model is built in the form of a classifier, and the classifier is trained on 70% of the data set, and the remaining 30% of the data set is used to test the model, and finally the model is evaluated based on different evaluation metrics. So the pre-processing step involves data transformation, where integer encoding and label encoder are used for transforming categorical variables to numerical variables, and due to the highly imbalanced nature of this data set, which basically contains data in the ratio 2.9 million records pertaining to normal transactions and only about 40,000 records pertaining to ransomware attacks. So this type of imbalanced data will try to distort the result. Hence we are using smooth or synthetic minority oversampling technique to try to balance the data before working on it. And of course data standardization is applied by using a standard scaler to standardize the data. And once the pre-processing is done, the model is classification model is built. Here 3 models were built: random forest classifier, XGBoost classifier, and balance bagging classifier. A random forest classifier is basically a classifier that is going to build multiple decision trees which are going to operate in cohesion. So the major advantage of going for a random forest classifier is that it's going to avoid the overfitting problem that the use of a single decision tree could have. This is done by reducing the variance, and this is achieved by the bootstrap aggregation concept, or shortly known as bagging. Bagging is nothing but constructing multiple decision trees and making each of these trees to work on the same data and try to find the result of the different trees, and the majority voting is taken, where the decision of majority trees are considered to be the final decision. So the other classifier used is XGBoost, or extreme gradient boosting classifier. This is an implementation of the gradient boosting decision tree algorithm. Again here a decision tree is involved, whereas the trees are going to be built and boosting is going to be applied. Boosting is nothing but build as new models are being built, the error rates of the previous models are incorporated to make changes and improve the accuracy of newer models. And to detect and correct these errors, gradient descent algorithm is going to be used here. And the third classifier is balance bagging classifier. This is very good to work with highly imbalanced data, as in our case, and this is again making use of bagging technique, where it's going to build multiple classifiers, and each of these are going to be made up of randomly sampled subset of the data, and finally majority voting is applied to find the final result of for classifying a particular data. And after performing the classification task, these are the result achieved for the different classifiers. Random forest classifier achieved 83.3% accuracy, XGB with 94.2%, and balance bagging classifier with 98.19%. And accuracy was not the only measure that was taken into consideration. The precision and recall were also considered, and the decision of finding the best model involves the F1 score too. And to also verify the result, so that the result is not biased, five-fold cross validation was also applied, and similar result was obtained. And this is the ROC curve that is being shown here for the three different classifiers. So from this it is clearly seen that the area under the curve AUC determines the amount of the ratio of true positive and false positive rate, or how accurate predictions the model is able to make. And AUC is highest for balanced bagging classifier, which makes this as the which makes it stand out among these three. So the conclusion of my work is that based on the performance of these three classifiers on the pre-processed data set, and comparing them based on terms of accuracy, precision, recall, and F1 score, it can be concluded that balanced bagging classifier outperformed the other two with an accuracy of 98%. Hence, this was able to identify the transactions and correctly classify them as ransomware payments, or whether they were normal payments. The future work could involve building more methods, or even building an ensemble method by combining different methods and testing the data on these ensemble methods to classify the transactions. Apart from that, hyperparameter tuning can also be employed by making use of a grid search mechanism to select the best hyperparameters for different algorithms to ensure that the classifier is able to work and achieve maximum accuracy. So that is all for this paper. Thank you.